welcome to True Projects. In this video, we are going to explain about a project titled Autonomous Tagging of Stack Overflow Question. The effective assignment of appropriate tag to questions is crucial for optimizing the content, discoverability, and relevance in online forums. Tags act as descriptive labels that categorize the question based on their subject matter or topic, streamlining the user search and facilitating the navigation through related content. This project focuses on implementing a robust system that automates the tagging process using the machine learning technique, ensuring the accurate and contextually relevant tags are assigned to the user question. By employing the advanced algorithm such as one versus rest classifier with a linear SVM, the system enhances the user experience by providing more efficient and accurate content organization, resulting in an improved forum engagement and satisfaction. The primary aim of this research is to enhance the user experience in online question forums through the automated assignment of tags to the user question. To achieve this goal, advanced machine learning techniques, especially the one versus rest classifier coupled with the linear SVM algorithm, are utilized. The objective is to accurately predict the suitable tag for the user question from the dataset containing of multiple labels. By implementing this automated tagging system, the paper seeks to improve the overall organization and retrieval of the information within online forums. As a result, users can access the relevant content more efficiently and enjoy a seamless and productive experience while engaging with the platform. Additionally, this project contributes the valuable insight and the solutions to streamline and optimize the content discovery process in online community platforms. And these are the basic requirements that are needed to build this project. Software requirements are Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, the necessary Python libraries are imported, like of NumPy, Pandas, sklearn are imported for the numerical operations, data manipulation, and the machine learning functions. Additionally, the natural language processing toolkit might be imported for the text processing and the feature extraction. And the second one is importing the dataset. The dataset containing the Stack Overflow question data is imported and loaded into the Python environment. The dataset likely include the columns like ID, title, body, and the tag. The dataset will serve as a foundation for the training and evaluating the autonomous tagging model. And the third step is building the model. Here, in this phase, the model construction process begins with the multiple approaches are explored for the autonomous tagging. Various features are extracted from the title and the body for each question, such as n-grams and the term frequency, inverse document frequency representation. And the first one is title n-grams. TF idea with one versus rest linear SVM classifier. In this approach, n-grams extracted from the question title serve as an important textual feature. Term frequency, inverse document frequency representation is applied to weigh the importance of these n-grams. One versus rest classifier and combination with the linear SVM handles with the multi-label classification task. It transforms the problem into multiple binary tasks, predicting the presence or absence of each tag in the question. By focusing on this question title, this approach aims to capture the key pattern and the keyword that contribute to the accurate tag prediction. And the second one is body n-gram TF idea with one rest was linear SVM classifier. Here, similar to this first approach, this method extracts the n-grams but from the question body for the richer context. TF idea is utilized to weigh the relevance of this n-gram within each question. One versus rest classifier with linear SVM continues as the binary classifier, facilitating the multi-label classification. Exploring the body test enhances the model's ability to capture the comprehensive information, potentially improving the accuracy of the tag prediction. And the third one is hand engineered TF-IDF with one rest and the linear SVM classifier. And this, incorporating the domain specified hand engineered features along with the TF-IDF representation is the focus of this approach. These features could encompass the various domain-specific characteristics extracted from the question content. One versus rest classifier with a linear SVM remains the chosen classifier adept to handling the multi-label classification task. By incorporating the hand-engineered feature, this approach seeks to exploit the domain knowledge and the contextual cue for the more precise and the tag prediction, aiming to enhance the overall accuracy of the autonomous tagging system. And the fourth step is training the model. In this stage, the model is trained on the labeled dataset using the features and the classifiers chosen in the previous step. The model learns to predict the appropriate tag for each question based on the input feature. The dataset is typically split into the training and the validation set to evaluate the model's performance and prevent the overfitting. And the fifth step is user gives the input. A user interface is developed using the Flask framework, allowing the user to input their question for the tag prediction. The Flask web application provides an interactive platform for the user to engage with the model and get the relevant tag for their questions. And the sixth step is the given input is pre-processed for prediction. The user provided question is pre-processed before passing it to the trained model for the prediction. Pre-processing includes the test cleaning, tokenization, stop-word removal, and the NLP technique to prepare input in a format suitable for the model. And the seventh step is trained model is used for the prediction. The pre-processed user question is fed into the trained model, which leverages the selected feature and the classifier to predict the most suitable tag for the input question. The model prediction is based on the pattern and the relationship it has learned during the training phase. And the last one is final outcome is displayed. The model prediction, that is the tag recommended for the user question, is displayed through the Flask-based web application. Users can see the relevant tag, aiding them in better categorizing their question and increasing the question's visibility and accessibility for the other users within the Stack Overflow community. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The dataset folder containing of the dataset and the testing dataset that are used in this project. And the static folder containing of the various folders like CSS, JavaScript, font, assets and images within it. And the template folder containing of the HTML document. It includes of home, index, notebook, result, sign in and sign up pages within it. App is an py file which contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operation such as processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the model is a file that contains the algorithm information that loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And notebook is an IPYNB file which contains a combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And to execute the project, we build a Flask framework as of the front end. And the overall project code is a combination of the code, output, and graphs, all are present in one place in the IPYNB file named notebook. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk to F because our code folder is present in F disk. Then write a command cd space and paste this code folder path. By this, the directory will change to the code folder path, and then write another command, that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on enter button. After running the app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser, and I prefer to use the Google Chrome. And then click on the enter button. Here we redirect it to the page containing of the title of the project and home and sign in and sign up buttons. Click on the sign up button. Here we redirect it to the registration form containing of some necessary details that are need to be filled to create an account. But my account is already generated, that's why I'm using the sign in button. Here it redirected to the login page containing of some necessary details like of username and password. We need to enter those details as of username, admin and password too. And then click on the login button. Here we redirected to the index page containing of some dialog box where we need to enter the question to predict the tag. And here I'm entering the message as Java 2D dimensional array, 2-dimensional array, values, I'm having a problem with my 2-dimensional array. And then click on the predict button to predict the tag of that message, and it is predicted as Java. And this way we can predict the tag of a question on the Stack Overflow. And by clicking on the refresh button, here we can enter the another question as of seems Android in some way preloads layouts and such problem occurs sometimes. But if I kill my process and start app, I always see this black screen. And then click on the predict button to find the appropriate tag for this message. I'm clicking on the predict button. Here the tag of this is predicted as of Android. And this way we can associate the tag of the Stack Overflow question. And in conclusion, this project aims to automate the tagging process for the user question and online forums, leading to the better content discoverability and relevance. Through the application of the machine learning methods, particularly the one versus rest classifier with the linear SVM algorithm, the system achieved the precise tag prediction from a dataset of containing the multiple labels. As a result, the user experience is significantly enhanced, ensuring that form content is appropriately categorized and easily accessible to the users.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.